In today's video, we're going to be talking about tree traversal and, more importantly, post-order tree traversal. Now, before we get started, let's get to understand what exactly tree traversal is. So, tree traversal in the most simplest form is a way of visiting all the nodes in a tree. This could mean that you're going through all the nodes and processing the data in some order, but as long as we visit all of the nodes in the tree, it would be considered tree traversal. Okay, so now let's talk about post-order DFS tree traversal. So post-order traversal is a type of DFS traversal where we have three main steps. And make sure to check out the other videos on in-order traversal and pre-order traversal, and so you get a deeper understanding of the three main ways of doing DFS traversal on a binary tree. But in post-order, we have three main steps just like in-order and pre-order, but the order is actually different. So the first step is actually to traverse the left subtree. The second is to traverse the right subtree. And similarly with in-order and pre-order, the final step would be processing the current node. And we do this all recursively or with a stack in a DFS fashion. Okay, now let's look at a post-order step-by-step traversal with the following graph. And I've purposely labeled the following graph in such a way that the output is going to be from A to H in order. Okay, so at each of the nodes, I'm going to have the following operations. Go to the left subtree, go to the right subtree, and then process the node. And this is all done recursively, so as soon as it hits one of these recursive calls, it's going to process it. Okay, starting at the root, we have left. So we're going to go to the left, which is E. We call left, go to the left subtree, which is A. Call left, there's nothing at the left. Call right, there's nothing on the right. And then finally process the current node, so let's print it out to our output. So now we're done with node A. So we can go back to E, and we see that we need to process the right node. So let's process the right node and traverse it. We're going to call left, so go to the left. Call left, go to the left. Well, there's nothing to the left, so call right. There's nothing to the right. And the final step would be to call node, which means process node B and put it to our output, and we're done. So now we're done with node B. We're going to go back to node D, and we're going to say, okay, call right. So we're going to call right, go to the right subtree, call left, call right, and then call node. And for the left and right calls, we had nothing there, so we could pretty much just skip those. So finally, we're going to call node, process node C, and now we're done with node C. So we can go back to D, and you can see the final call that we have is node. So let's call node, and let's process node D. Okay, so now we're done with node D. We can come back to node E, and we can see the last call that we have is node. So let's call node. Let's process node E, and now we're done with processing node E. We're going to go back to H, and we can see that the call that we need to do is right. So let's call right. Let's go towards the right. Let's call left. Well, there's nothing to the left, so let's call right. Then let's go to the right. Call left, there's nothing to the left. Call right, there's nothing to the right. Call node, process the node, so F is to our output. And now we're done with node F. Now let's call node on node G. Let's process the data. And now we're done with node G. And now we're back at node H. And the final step that we need to do is call node. So let's call it and process the data. And we're pretty much done. So now you can see that the output consists of A, B, C, D, E, F, G, H. And that's exactly what the post-order tree traversal of this current tree would be. Okay, so let's look at the pseudocode for this post-order traversal. So let's assume that we have the following definition for a tree or a node. So it has an integer value, which is the current node value. This could be anything, and we can have a lot of these different things inside the current node. The next one we have is node left, which is a pointer to the left node. And remember, we're using a binary tree, so it only has left and right. And finally, we have node right, which is a pointer to the right node. In terms of the pseudocode for the post order, it's very similar to in order and pre order. So all we have is a void method called post order, which takes in a node. If the current node is null, then we just basically return nothing. And otherwise, we're going to basically just do post order on the left, post order on the right subtree, and then process the current node. So this is the pseudocode for post order traversal. Okay, so what is the time complexity for post order traversal? Well, it's really similar to in order and pre order. Each node is visited exactly once. So what does that mean? That means the time complexity is O of n, where n is the number of nodes. And that's pretty much it for post order tree traversal.